Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers approximation. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 15. A cinema has 37 rows of seats, 23 seats in each row. Adult tickets are £8 each, child tickets are £6 each. The cinema has sold tickets for every seat. The manager estimates that £6,400 was raised from these tickets. 200 child tickets were sold. Check whether the manager's estimate was close to the exact amount of money raised. Okay, well, got quite a lot of work to do here to work this out, haven't we? So where to start? Why don't we start off with working out how many seats there were altogether. So total number of seats. Now that's going to be 37 times 23. Okay, how do you do your multiplication? Maybe do column multiplication. Maybe you use the grid method. I tend to recommend students use Napier's bones. So I'm going to quickly do that. So a little grid like that with diagonal lines drawn in. So 37 along the top, 23 down the side. 3 2s are 6, 7 2s are 14, 3 3s are 9, 7 3s are 21, and then with Napier's bones you add up along the diagonal, don't you? You seen this method before? So that's 1, 4, 2 and 9 add up to 15, so just carry 1 into the next diagonal. 1, 6 and that carried 1 adds up to 8 and that's 0. So once you've gone round like that, then your answer is here. So that equals to 851. So there are 851 seats altogether. Okay? So we've dealt with the number of rows and the number of seats over there, and that gave us 851. Okay, where to go next? So we've got 851 seats all together, and we know that 200 child tickets were sold. Okay, so from that we can work out the number of adult tickets and child tickets that were sold altogether. So we know that there are 200 child tickets sold, so adult tickets is going to be the total number of seats less the number of child tickets sold, which was 200. So that is 651. Okay, so we got adult tickets 651 and child tickets 200. Okay, so we know that adult tickets were £8 each and we know that child tickets were £6 each, so we can work out the amount of money coming in now then. So total income is going to be our 651 adult tickets times an adult price of £8 plus 200 child tickets at £6. Okay, well, part of that is easy to do. 200 times 6 I know is 1200, so I can just write that one in. 651 times 8, it's not so easy to do in my head. I'm just going to do that as a separate calculation. Again, I can use Napier's bones method. So this is a 6 times 1, sorry, 3 digit by 1 digit grid. So 651 times 8. So 6 8s are, what, 48? 5 8s are 40. 1 8 is 8. And then adding up along the diagonals, that's 8, 0, 12, carry 1, 5. So my answer is 5208. So that's 5208 for the adult tickets, plus £1,200 for the child tickets. Adding those two numbers together, that is 6408, isn't it? £6,408. Okay. Right, so you'll remember the question wasn't how much did we make, it was to check the estimate of the manager, and that the manager estimated it was £6,400. Now if we worked out it's £6,408, so looks like the manager was pretty much spot on, wasn't he? So I'm just going to write down the manager's estimate was accurate. Jack works out the answer to the root 98.5 minus 12.1 divided by 0 minus 0.8, and he says the answer is negative. Is he correct? You must show your working. Okay, so let's have a look at that top line there. I've got the square root of 98.5. Now that is approximately 98.5 is not a million miles away from 100, so the root of 98.5 is roughly the root of 100, which is about 10. Okay, now actually the real answer is going to be slightly smaller than 10, but if I take 10 and I subtract 12.1, I'm going to get a number less than 0. So that is going to be negative. Okay, and then so the top part of my line is going to be negative, and then I'm going to divide it by another negative. It's going to be roughly minus 2. So it's going to be roughly minus 2.1, isn't it? And if I take minus 2.1 and I divide it by minus 0.8, I have a negative divided by a negative, which is positive. So Jack must be wrong.
Question 20. By rounding each number to one significant figure, estimate the answer to 78 times 11.6 divided by 391. You must show your workings. Okay, so rounding to one significant figure, the first significant figure is the first non-zero number of your number that you're looking at. So in 78, the first significant figure is the 7, which is in the tens column. So basically what you're being asked to do is round that number to the nearest 10. Okay, so 78 to the nearest 10 is going to be 80. 11.6, again the first significant figure is the first non-zero digit, which is the 1. And again that's in the tens column. So again we're going to be rounding that number to the nearest 10. So we're going to be, 11.6. Which 10 is it nearest? It's nearest 10, isn't it? So 80 times 10 divided by 391. Now the first significant figure of that number is that 3 there. That's in the hundreds column. So 391 we're going to be rounding to the nearest 100. So 391 to the nearest 100 is 400. So I've got 80 times 10 divided by 400. So 80 times 10 is 800. 800 divided by 400. Well, 400 goes into 800 twice, doesn't it? So it's roughly 2. So 2. Question 7. By rounding each number to the nearest 10, estimate the answer to 61 times 47 divided by 102. Okay, so let's round off each number first. So 61 to the nearest 10. Is it nearer 60 or is it nearer 70? Well, it's clearly nearer 60. 47, is that nearer 40 or is it nearer 50? 5 or above rounds up, 4 or below rounds down, so that's going to be rounded up. 102, is that closer to 100 or 110? So 2 rounds down, so that is 100. Okay, so I've got 60 times 50 divided by 100. Okay, now I'm going to divide one of those, I can cancel one of those 10s into there, and 1 into there, and it leaves me with 6 times 5 divided by 1, which is just 6 times 5, isn't it? 6 times 5 is 30. So my estimate is going to be 30. 13a, some more calculator work. Use your calculator to work out the exact value of 18,953 times 437 divided by 11. Now this is written as a quotient. You could just use the fraction key to write it down exactly as it appears on the screen. I think that's what I'll do here. So hit the fraction button first, and that gives you a space to write in your 18,953 times 437. Then press the down button and then type in the 11. Okay, done. So let's press equals and we get what? 752,951. Okay, part B says use approximations to one significant figure to check if your answer to part A is sensible. Okay, so approximating like this is quite a good way of just double checking your work, because you can do it quickly in your head. So if I was to round off each of those numbers to one significant figure, I'd be rounding that one off after the first digit. It's got an 8 after that, so I'd be rounding up, wouldn't I? So my first number is going to round up to 20000. Remember, your rounded off number has to be the same magnitude as your original number, so I can't just write in 2 and say that's a good approximation to 18,000. If someone owed you 18,000 and said let's just round it off to 2, you wouldn't be very happy, would you? But 20,000 is an approximation to 18,000. And let's multiply that then by, what's this next number rounded off then? So rounded off after the first significant figure. My next digit is 3, which means I need to round down. It's going to stay as a 4 then, isn't it? So it's going to be times 400. And then divide all that by 11. Well, 11 rounded off to one significant figure. Round off after the first digit. The next digit is 1, which means I round down. I'm going to round that off to 10. Okay. So what I'm going to do is I'm going to cancel that 10 into one of those zeros on the end there, and I've got 2 times 4, which is 8, and then I've got 1, 2, 3, 4, 5 zeros to add. 1, 2, 3, 4, 5 zeros. So my approximation comes out to 800,000, and my original answer was 752,951, which is 800,000 to one significant figure. So I'm going to say yes. My answer is sensible. I don't know if you have to write that down. It's not really clear, but there we go. I've done it now. Question 14a. Use your calculator to work out 9.95 squared times 29.8. Okay. So we've managed to gain quite a few marks already in this paper just by being able to type nicely into my calculator. So 9.95 squared times 29.8 equals. Write down your full calculator display. So 2950.2745. Okay, that's what I got. Right, question 14b. Is your answer to part A sensible? Use approximations to decide. You must show your working. Okay. Oh. So what asking me to approximate that answer now and compare it with my answer to make sure that I did it correctly. Okay, so let's do that then. So if I look at 9.95, I'm going to round each one of these numbers off to one significant figure. So the first significant figure in 9.95 is the 9, which is in the units column. So 9.95 to the nearest unit rounds up to 10. So I'm going to get 10 squared times 29.8. So the first significant figure of this number is the 2, which is in the tens column. So let's round 29.8 off to the nearest 10, which is 29.8 is nearest to 30, isn't it? It's nearer 30 than 20. So it's going to be 10 squared times 30. Okay, so let's work out down here 10 squared times 30. Well, that's just 100 times, not 106, 100 times 30, which is 30 with 2 extra zeros, 3,000. Okay, so my estimate was 3,000. My actual answer was 2,950. So that's not bad, is it? It's only 50 out, which is not too much when you're talking about thousands. So yeah, I'm going to say it was sensible.
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.